doing the same problem. Okay. Is that coming on?
Go to start.
Yeah. So, good evening and welcome to this month's talk of Varaha Mehra Science Forum. My name is Gopu. Before we get into the speaker's presentation, I'll give a brief introduction to the series of programs that we have done so far in Varaha Mehra Science Forum. We started this a few years back as a general forum to introduce topics on science and technology to the public at large, not just to technical audiences, but to anybody who was curious about science and not have to go to specialized institutions or organizations, like IIT or a medical college or in any college in general or a company, but have it as an open forum where the public can attend these talks. So we invite both professionals and amateurs to give talks on various topics, and we started it off with a lecture by me on Lavoisier and the origin of modern chemistry. So after that, we had a talk by Badri on single helix, double helix, the discovery of molecular structures of the cell and its components. We had talks about we had to talk about phages, bacteriophages, the small virus-like creatures that were used before antibiotics. Talk about Isaac Newton. Most of these were by amateurs, not necessarily specialists in the field. We had a talk by Professor Krishnaswamy Alladi of the University of Florida about his father's contribution to establishing a physics seminar in Madras, and then how it led to the formation of math science. And he talked about how Nobel Prize winners like Niels Bohr and Marie Gelman and others visited Madras and gave lectures to specialized audiences. So the concept of science lectures is not special; it's just not continuous and organized like we have done in the last couple of years. We had a very generic talk by Akash Narayanan, who's now doing a PhD at the Fermi Lab in Illinois. He gave a general talk called Atomic Theory for Alamut. But we had a geologist called Singananjan, unfortunately passed away. He was former director of GSI. He talked about rivers and coastlines and how they have changed, not in geological time, but even historical time. We had Venkatesh Ramakrishnan, a writer, talk about the advent of technology in Madras, how this tradition, the city that is kind of known for tradition, adopted a lot of technological developments. When was the first plane introduced, water management, electricity, telephone, trains, all kinds of other technological, a historical view of all the adoption of technology in Madras. Narasaya, a former chief engineer of the INS Vikrant, talked about his life as a marine engineer and his career in the Navy and in the Merchant Navy. We had talk about the Indian monsoon, about Tamil work called Asthana Kolakalam of the 15th century by Dr. Sita Sundaram. We had Professor Dayanandan of the Madras Christian College, a biologist, I think the first professional to speak in his own field, besides actually after Singanandan, I guess. Speak about the evolution, the grand heritage, and he traced the entire history of evolution and biology until today. I gave a talk in Tamil about astronomy of ancient cultures. We had Arvind Gupta, the Padma Shri winner, who's delighted children over the years with his toys. It was one of our best attended programs. He demonstrated a number of toys and principles through toys that he has devised. He has a website and people went and looked it up and made some toys and all that. We had a talk about the construction of the Periyar Dam, about women engineers. Dr. Uttara Durarajan was HOD of physics at DG Vaishnav, talked about women scientists of India. Then Dr. Venu Ramachandran, the neurologist from California, gave a talk about the heuristics of scientific discovery. It was also one of our best attended programs. He gave another talk about relevance of Freud in modern neuroscience. Badri gave a talk about structure of ribosome, the Nobel Prize winner Venki Ramakrishnan's work. So we had Dr. Satish Kumar Saravanan, a researcher from the University of Leibniz, talk about the brief history of gravity. We had a meteorologist talk about weather and climate in Sangam poetry. And so a lot of talks like this, CRISPR, which is kind of relevant. Ramanan spoke about CRISPR. We had a history of neuroscience, the story of light, nutrition, about chemical discoveries of covalent bonds, children doing experiments, the life and works of C.V. Raman. We also conducted a couple of courses on Indian astronomy and mathematics. I conducted a course. I've done 4 batches so far. We had children from a nearby school, in a village school at Sevalaya near Tirunendravoor, show there. The teachers of the school showed, what they learned from installing a sundial at their school and what, they have been teaching the principles of astronomy to their students. We had another lecture by V.S. Ramachandran, the art of scientific discovery. We had Ramanan talk about the spread of viruses information at the start of the corona infection. Badri taught a workshop on Kuttaka, linear intermediate equations, as set out by Aryabhatta in his book Aryabhatta EM, and later developments on that front. We had Dr. Ravindran of IIT talk about artificial intelligence, a very general overview, a very good introduction about it. We had another geologist, Pranay Lal, talk about the Thar Desert and its natural history, starting all the way from 3 billion years back until today. We had a very interesting talk of a lesser-known mathematician who lived in Kumbakonam, Sundar Rao. Professor Arun Srinivasa of Texas A&M gave a talk about learning geometry through paper folding. We only associated paper folding with origami in Japan, but he gave a talk about mathematician in Kumbakonam who had done this, who was almost forgotten. Badri talked another lecture about another workshop about Bhavana and Chakravala, Bhaskara's second order equations, quadratic equations. We had Saman Subramaniam talk about JBS Haldane, a biologist and a mathematician who came to India after India became independent, settled here, established a research center, and so on. And so with that, we come to today's talk, and I will let Rajagopal introduce the speaker of the day.
Yeah, thank you, Gopu. I'll give a very brief introduction about today's speaker. Obviously, today's speaker is very well known in the academic, technological, and scientific community of India. Dr. Kamakoti Veezhinathan is a professor of computer science and engineering at IIT Madras. He specializes in the area of computer architecture, information security, and VLSI design. He also heads the Microprocessor Development Program and the Information Security Education and Awareness Program funded by the Ministry of Electronics and Information Technology, Government of India. He was the chairman of the Artificial Intelligence Task Force constituted by the Ministry of Commerce and Industry, Government of India. Welcome, Dr. Kamakoti. And today's session, briefly, it's about the Shakti Processor, the first open source initiative by the Reconfigurable Intelligent Systems Engineering, RISE group at the IIT Madras, which was to develop the first indigenous industrial grade processor. The aim of Shakti initiative includes building an open source production grade processor, complete system on chips, SoCs, development ports, and the Shakti based software platform. The primary focus of the team is architecture research to develop SoCs, which is competitive with commercial offerings in the market concerning area, power, and performance. Today's talk will focus on chip design and fabrication, the strategic importance of self-reliance in the area, and the story of the Shakti processor, and a lot more. Over to you, Dr. Kamakoti. Welcome aboard, and over to you. Yeah, the floor is yours, Dr. Kamakoti.
Yeah. Is my screen visible? Am I audible?
Yes, yes.
Thank you very much, and thank you very much for inviting to this very wonderful forum. I see a lot of speakers before me who had achieved quite a bit in life. So thank you for considering me. to give this talk. This talk actually becomes a very important project of national importance that we took up in the year 2012. And what I'm going to do basically is to describe this journey from 2012, the last 8 years, and what we have achieved at this point of time. So this is the basic flow of what I'm trying to do in the next 45 minutes to 1 hour, and I'll be opening up for questions. So, so I call this talk as Shakti for Bharat. Shakti is the processor for our country. So I belong to the Computer Science and Engineering Department of IIT Madras. We have a center called Pratap Subramaniam Center for Digital Intelligence and Secure Hardware Architecture, DISHA. If you just take the first letter, it's called DISHA. It's funded by alumnus Pratap Subramaniam, who is alumnus of IIT Madras, and he has funded close to $1 million to this particular center. This center comes under a group which we founded in 2005, myself and Professor Ravindran, who also has been a speaker in this forum quite a few months before. We call it as Reconfigurable Intelligent Systems Engineering Group. Why I'm mentioning that is around 2005, we did realize that with the advent of AI and the IoT, the Internet of Things that is coming up, there will be a need for actually having domain-specific architectures that suit a particular domain. And in that context, it needs to be reconfigurable, and at the same time, it needs to be intelligent to do a lot of actions at the edge. For example, I put a sensor, I have a processor near that sensor which collects data. That processor does need to make certain intelligent decisions. So that's why we call it as Reconfigurable Intelligent Systems Engineering. And this group was formed in 2005. And then we have grown. I'll talk about this. I'm also a member of the National Security Advisory Board and also a member of the Mission Steering Committee of the National Digital Health Mission. So these two are of strategic importance. And so while I'm presenting the microprocessor, I also give a national perspective of why it is important. So this is my overall agenda for today's presentation, and I hope I'll make it meaningful and also interesting to you. So my inspiration started in 2012, around 2012, where Dr. Kalam made the statement, my 2020 vision for India is to transform it into a developed nation that cannot be abstract, it is a lifeline, right? That's the second point is very, very important, right? And abstract in our sense is a bunch of papers of concepts which are yet to get translated into a product. What we need is products that work on the floor, on the field, and it should scale up and it should meet the international competition. And unless we see that, transforming ourselves into a developed nation is again a sort of a story that we will keep repeating. And that is one very strong statement during this. He had been repeating at many places, and once in IIT Madras also when he came around 2011-12 region, that really I got inspired about. So around early 2012, myself and Madhusudan Deshigan, he was in the industry, and he just came casually one day to my room and we started discussing. And we said, let us start doing something concrete for the nation. And so around early 2012, we thought that we need to deliver something that can benefit our country. It should not be abstract, it should be a lifeline product. And we kept 2020 as the goal. And whatever we can, right? So whatever our expertise is, everybody can do something from the expertise, and that's how a nation is built. The processor actually became the obvious choice. And as I proceed in this lecture, I'll tell you why we made it as an obvious choice. So with Madhu, myself, we actually conceived the Shakti program, and our motto was very clear. Even at that time, our Honorable Prime Minister mentioned this word. We were very happy to listen in a recent speech. Sarvam Atmavasham Sukham, Sarvam Paravasham Dukkham. Anything that is under my control gives me happiness. Anything which is in other control for which we have the dependency gives us sadness. It gives us sanctions. So what we wanted was, we wanted to make a microprocessor which has no encumbrance, no sanctions. I should not be worried when I open up a strategic program whether this processor will be available at all or not, and am I dependent on some other country for its availability. So it should be an indigenous development. And it is not that making a processor, as you will understand as we are proceeding, it is the entire ecosystem that we need to build. A processor cannot be built on isolation. It is the ecosystem that needs to be built. And this was something that we kept in mind. And this was the early discussions that happened in 2012. So the first dedicated team, Dr. Neil Gala, that time was a young internship from college, and today has completed his PhD and is with me still for last 10 to 12 years. Now, Venkat, Shankar, I'm just mentioning these people's names because they are the backbones of this program. Rahul, Arjun, Vasan. So these 6 people were there with me at that point of time. And please note that they have given up and continue to give up very big salaries in MNCs, not 1 rupee. I can proudly tell that Dr. Neil got close to ₹500,000 per year without an interview in a MNC. And he dished it. Similarly, Venkat, Shankar, Rahul, Arjun, and Vasan. And they continue to give up big salaries in MNCs and just to realize this Shakti vision. Why I'm presenting here is at least 3 of them in this list. The remaining 3 are close to my age, at least that we discount. But the remaining 3, 50% of this are youngsters who bet their career for the sake of the country. And I still believe, and I continue to believe, and I will believe that India is in very safe hands with these type of individuals around, youngsters around. Now, what is the challenge in front of us? If you take the electronic design and manufacturing process, there are a bunch of 8 to 9 steps. You see there is a system specification, something in your mind, then it comes out as an architectural design, then you convert it into a functional design, logic design, then you convert it into a circuit, and then you do something called a physical design, which essentially involves a bunch of other 6 steps like partitioning, floor planning, placement, clock that goes to the different parts of your circuit, your routing, and then finally saying this processor will work at this speed, at this power. We call it as timing closure or power closure, etc. Then you do a physical verification. All these things are done in software. Okay, so this is all soft models. And then you make a mask, and then that you send for fabrication. It gets fabricated, then it gets packaged. They do a preliminary testing and send you back the chip. So very, very, very at say 6,000 feet view, this is the set of flows that happen when you want to make a chip. Now, where is India today? If you look at the first part, from system design to physical verification and sign-off, India is world-class, right? Some of the biggest design, most complex designs are done in Bangalore, though it may be in MNC's Indian offshore office, done by Indians. So we are world-class in the first part. If you just look casually, I just went for, I'm just trying to give you some indications of where we are. I was called by an MNC to give a talk, and then during this COVID time. So I just counted how many of my students are there. In the last 20 years I've taught at IIT. I found that 85 of the 170 people are my students who are sitting in that MNC. So what I'm trying, if we put all Sigma IITs and NITs and all the engineering colleges together, I think we will, many of them would have been our students rather than somebody who has studied abroad and come and joined here. So that's the most important thing. So we are world class and they do world class products. But with respect to fabrication, packaging and testing and chip, we lag by 2.5 decades. And that is the biggest challenge. So the moment we say that I want to make an electronic design in India, when you want to market that design, you have to show something called silicon proof. Essentially, it works on the field, right? From paper, it has to go to wafer, right? It has to work on the field. And to show that, you need a fabrication facility. And unfortunately, that is where India lags today. And it has been lagging and it lags today. And hopefully, there are a lot of efforts now to bring it up to shape. But this remained to us as a challenge. Hey, we make a processor, where will we manufacture it? Just we show a simulation model. Will people be convinced about it? Will somebody use it? So these are some things that were sticking on our mind at that point of time. So our initial thought was that 2020 is a marketable stuff. It is not that something that I do as an academic project and give some grade to a student. And we have to compete with the billion-dollar processor industry, right? And something we have to make some mark there. And if it's not, then we are in soup, or we don't achieve this goal. And manpower, if you look at these processor companies, they run 3,000, 4,000, per team there will be 200, 300 engineers working at different aspects of this. And we are a very small team. And that time we did not also have funding. So we are a very small team. And in academic institution, we run a company with 100% attrition in May and 100% fresh recruitment in June, right? And because one batch finishes, another batch comes in. And so how are we going to manage that? And software plus hardware will make a processor. Should we do both? Should we do the software plus hardware, or should I do only the hardware, or should I do only the software? At least put it onto a commercially off-the-shelf hardware. So these are all some of the questions that came up, and we had to make certain decisions which would be quite good in 2020. So 2012, we had to make a decision that will be valid in 2020. So the initial decisions at that framework between 12-13, that academic year where we were discussing, is we need to go with the open source software stack that is very effective. So we may not reinvent all the wheel, but we need to have an open source software stack, certainly, where I get the open source and I develop skill set to go into it and start maintaining it by one. Because Atmanirbharta, that's what we are thinking of, that indigenous thing should be very crucial at that point of time. And we need to take up a hardware for which software is already stable, and we will make the hardware. Because there was a question between whether should I use the software or should I use the hardware. We said, so should I make the hardware? We need to make up the hardware, and let us take a software that is already stable and port it onto this hardware. Now, what do you mean by taking up a hardware? Taking up a hardware essentially means that the software actually communicates with the machine through what we call as a machine language, and that interface is called an instruction set architecture. This is a bunch of machine language commands that the machine will understand, and essentially your software should translate to these machine language commands for the machines to execute. So, so the machine language, the instruction set architecture is what we need to decide. If I say I want to make my own processor hardware and use an existing software to do on this. So at that point of time, we started with IBM Power. And because Open Power was there, and so myself and Madhu went for a discussion with IBM, and that's the name Shakti came. So we said we'll do Power because he says it's Open Power. So let us do the microarchitecture of Power and take the entire IBM stack and push it onto this. Okay. So at that point, when we approached IBM, then they said that the initial cost of joining the consortium, the open source consortium, is $20,000. That itself, we did not have the funding. And second thing is that, and there were too many regulations about using it, and there was too much legacy also. So it will take at least 4 years for us to understand the entire software stack and understand how we make an architecture that will suit this software stack, right? And too much legacy. And we said that this is not going to fit the 2020 deadline. So if we are not going to achieve something in 2020, I would have been happy teaching and doing Sahasravarti Gayatri every day. Okay, I would have gone, I'll think about the next world. But if we want to do something, then we wanted to hit this nail on the head. So that's why we said, okay, this is not going to fit. So then we were also looking at funding. So if you look at the processor companies, they invest billions of dollars for doing such processors, billions of dollars. Even the lowest end of some of the commercially available processors, they claim they have spent billions of dollars on that. So these were some of the initial decisions, but we were very clear that we will take an open source software stack and port it onto the hardware, whichever hardware we want to decide upon. And this is where the dilemma started. And 2012, we were about to say, oh, maybe it's not possible now. And that where, when intentions are good, God is with you. The God, in my name of my Guru, the Paramacharya of the Shankaracharyas of Kanchi, gave me these great blessings. And that is where we got this beautiful thing, the RISC-V open source ISA. Quite interestingly, we were approached by Berkeley saying that we just circulated saying we are interested in doing an open source through the IBM and other things. There was a noise that we made that we want to do the processor for our country. That time we were approached saying, hey, we are coming out with an ISA because one of the contemporary processor company actually kept their bus interface. The bus is one by which you can attach a peripheral to it. The bus interface it kept open. And at that point of time, they said they are also trying to close the bus interface, but it becomes proprietary. And if the bus interface actually becomes proprietary, you cannot even make a peripheral in this world without the permission of that particular contemporary, without the certification of that particular hardware company. And that's it. So this is essentially a monopoly. And I think that is one of the reasons why Berkeley came up and said that we are going to do this RISC-V. V stands for Phi, the Arabic Phi, and RISC is reduced instruction set computer, Phi, the new instruction set architecture. And what they assured us at that point of time, it will be an open source ISA, no encumbrance, no sanctions, right? It will come with you. It will be released in one of the very free licenses, and they did release it in this thing. And they also ensured that there were already some other agencies who joined hands like Cambridge, etc., who started developing the software stack for this. So the crucial decision, it was a one-night decision where, I still remember a night 9:30 to 11:30 call between me and Madhu, where we said, okay, if we are going to make, so I don't know that at that point of time, we never thought that, we'll make it as an India microprocessor, but the microprocessor that we will do should be RISC-V. And, but the only the thing is that how will it be in 2020? So we start this effort, but in 2020, what will happen? Then we spent a couple of days to understand the strength of RISC-V. And first and foremost, we said, one of the best architects in the world are joining hands to make this. Let us go and analyze this. Then we found something phenomenal in the RISC-V instruction set architecture. It's very extensible. It is actually the architecture of the future. It has all the bad qualities of a legacy architectures gone, and some very interesting new things in this place. I'll not have time to talk about RISC-V, but some other later time, if there is a select audience in this forum, I can come and talk about RISC-V, why it is good. So that gave us the confidence. And so then we said, okay, now we have to look for funding. So we proposed in 2015, 2 years after that, to MeitY saying to Government of India, the Ministry of Electronics, that we must go with RISC-V and this is a project proposal. Why don't you consider this and fund us so that we will do something and give you something some concrete in 2020. Now, what was inside our roadmap? So we just started looking at AI in 2014. And we saw the boom of IoTs that is going to come from all the reports. And we essentially made that there is no point in making one microprocessor. We should need to do a family of microprocessors. If the family of microprocessor is there, then only it gives you that real sufficient in. And so at that point of time, what we thought was, so in the ensuing IoT era, we will have some processor that will do some micro sensing. Right? You put it with a pollution sensor. You put it with a weather sensor or temperature sensor. Safety lock. That we call it as D1, which is actually an environment monitoring type of a processor. That is attached to a sensor, collecting data and doing some action. Then the D2 is a sort of a medium edge device sensing, which could go into industry 4 type of process control, vehicular electronics, or point of sale terminal, etc. Then these are going to give some information to to a D3, which is slightly a large edge device aggregator, which will be your network routers, your mobile phones, your desktops, workstations, etc. For example, Arogya Setu, the D3, which is the aggregator of the data sends through a Bluetooth interface, is a mobile phone. Right? And D4 is, of course, the decision-making and monitoring environment, where you have a cloud or a transaction processing or a supercomputing environment, doing machine learning, AI, etc. So we need at least 4 classes of processor, or to bridge this gap, and that is where we thought, okay. So our entire Shakti roadmap had been inspired by this distributed AIML, which we thought as early as 2014 will certainly be of relevance at 2020, and so that was one more decision that we made, and that fortunately, by God's grace, by Paramacharya's grace, it has come to true that today it is coming. We are seeing that type of a booth. Now, so based on this need, we defined what should be our processors. The goal, again, I told you this is not a graduate degree project or a research that goes into a paper, right? We did publish papers on this, but this is a system that could work. And then we were very much reminded by the Tamil statement, Padugalatla no uppari, okay? It is work or not work, and it should work. So we had to define, we had to tell what these processors are, and we spent actually quite a significant amount of time to define these processors. In somewhere around 2016, we called something called E class, which is an embedded class. It will be sub 200 megahertz, quad SPI, UART, I2C, these type of interfaces will be there, pulse width modulators, and this market equivalence will be the Cortex M series. Then we were talking about C class, that is below. It will be a 3264-bit, but it will be a 5-stage pipeline, right? And with a lot of things, and it should also boot Linux. And so this would be a market equivalence of ARM A35, A55, or Intel Atom. So we were trying to compare that. And the C class is what we have actually manufactured today. I'm coming to the story. We have 2 chips that are manufactured, one working at from one with the Chandigarh fabrication facility within India, and another at the Intel Oregon fabs. The last one, actually on the right hand top, is the I class, which is a 8-stage pipeline. Today it has become a 12-stage pipeline. It's a dual issue out of order, and we were looking at ASIC tape out readiness by end of 2019. It has skipped because of our COVID thing. So we will be at year delayed, but we are doing ASIC tape out readiness very shortly, and that will be a sort of market equivalence of A9 and A15, but we have increased the scope to meet A75 there. Okay. So these are the basic building blocks. The E class, I class, and C class are the basic Shakti cores which will power these systems. And what would be unique about it? I don't want, I really hate somebody to buy because you are Indian, so I'm buying even though you are inferior. We wanted to be world class. We wanted to have a unique selling point here. And this unique selling point essentially comes from the 2 parts that we are talking of. F class, which is what we call as a fine grain fault tolerance, and T class, which is a tagged instruction set type of architecture, but now we have added a lot more security features, which is a secure variant, right? So the security and fault tolerance, along with edge intelligence, is what we want to fit onto this E class, I class, and C class, and make these processors unique to serve this entire IoT game at the D1, D2, D3, D4 levels that I have been describing in the previous slide, right? So this is the unique selling point, and this is where we pitched it. Right, now we wanted to address, see, with 100 man years to make a processor, what are we going to do? We have some, say, 5 or 6 people who are continuous. The initial team I introduced, they are there with us, but then what else? Then and that is the point where this blessing came, that we had been using a language called BlueSpec. BlueSpec is a way by which I describe the design, right? So I have a design in my mind. I have to basically tell the computer, hey, this is how the design should be. There should be a language in which I need to communicate. These are called hardware description languages. So there were languages called Verilog, VHDL, which were there, but they are the ones that create a lot of problems in terms of modeling. Now, BlueSpec was that design. We started looking at BlueSpec as early as 2005. We have a long relationship with BlueSpec. And then that gave us, I must say, I have certain measurement. I'm not projecting the measurement today due to paucity of time, but we had 250x more productivity. And that essentially means that we were way ahead and we could meet this great $1 billion investments in these processor designs. And what we did was we started certain projects for strategic agencies. I can't mention the name of the agencies here, but we did start, and we made some equivalent complex designs for them. And we also made certain end-to-end products. For example, one was the wireless sensor network moat that myself and Venkat was involved. We did it for railways, where this moat will be on the track. It will be sleeping in deep sleep mode, and when a processor, when a train comes, it wakes up because of an accelerometer, and then it measures the strain and stress on the strain and acceleration on the steel bridge, and it communicates back to a server at IIT Madras saying this is how, and by that we were able to monitor the structural health of the steel bridge. This was a very easily defined problem, but when we actually implemented, it's a one-year project, and that actually gave us a lot more insights of what is the expectation of a end user from a processor environment. And these two projects, I must tell, has indeed blessed us, and we thank some of the strategic agencies for supporting at that time. And that also gave us some money to keep the team with some minimal payment, so that we kept a project running. BlueSpec was a commercial software at that point of time, and BlueSpec was very kind enough. So I was sentimentally attached with BlueSpec. My BTech student actually went to MIT. This BlueSpec was promoted by MIT, and he was involved in this project. So I was also sentimentally attached to this language, and it also was good in other sense. And so they gave us around 250 licenses free to IIT Madras, saying use it and do whatever you want. So gracious of them. And then we started this entire project program. So we decided that India's microprocessor from our stable, what is going to come, will be based on the RISC-V architecture and the BlueSpec language. So www.bluespec.com is where you can visit and take more clues about this language. It's a fantastic language. Now, November 1, 2017, five and a half years after we really conceived of this program, we started looking at the program. We got a sanction of 11 crores. It's almost $1.5 million at that point of time to do two versions of the microprocessor, the C class and I class, and two tape outs had to be done. Sorry for the typo there. Two tape outs had to be done. And this is really what the Ministry of Electronics and Information Technology gave us as a project. At that point of time, so since we are betting at 2017, RISC-V actually became an open source consortium with around 300 members at that point of time. And today it has 1,000+ participants. And some of the big companies of the world are moving to RISC-V, and we are in very close touch with them. And the other interesting thing that came out, the language in which we were describing the BlueSpec also became an open source language now. And so this essentially completed the cycle for us. And the latest news which happened last week is IIT Madras will be in charge of ensuring compliance of RISC-V globally. And that has been a big achievement for our group. And thanks to my entire team for having achieved this. So these are some of the blessings in disguise. And so that means we have complete control over what is going in and what is going out on the standard on which we have bettered our India's microprocessor. So this is a very crucial thing that has happened. So these are the Shakti movements. This is my team, my wonderful team, and they have been with me. Lots. I'll show a bigger photo at the end of the real people who are involved. So we had Dr. Shivan visit us, Vice Admiral Raman Puri, who visited us along with General Shankar from the army. And this is what you see on the middle, where everybody is kneeling down. This is on the day we booted our 22 nanometer chip. What you see on the left-hand side, bottom, that's where we booted the 180 nanometer chip on that day. And these are all some of the very interesting moments of Shakti, which I personally will remember forever. So in the year 2018, this is the on July 21, 2018, where I actually turned 50. On that day, on that evening, my father said I was born at 10:50 in the night. exactly around 10:30, I got the news that this chip has booted. So one satisfaction for me is before I turned 50, at least something I have delivered, which is worthwhile to the country. So that was a big feeling. I'll never forget it, and I'll never forget the team which has enabled to do this. It was not just my effort, the effort of 20 plus young people who have spent the time. And what did we achieve? At that point of time, we were the lowest power consuming RISC-V chip in the planet. And we had 300 megahertz operating frequency for a C class, which is very good. And then we had all the things like DMA, tightly coupled memories, JTAG, and 100 Ks. And note that everything was new for us. The team was new. First tape out. Even personally, I have not done a tape out in the past. Everything was new. Intel gave a free silicon run for us. 22 nanometer would have cost millions of dollars. That came free for us. HCL Technologies pitched in. They gave us many manpower who came and helped us with some of the backend at the crucial moments. And of course, our IIT Madras, which gave me unstinted support through our industrial consultancy and sponsored research division and our director, everyone. So this was the tape out in 2018 that we finished off. And at the same time, we had another chip that was being fabricated, the Remo. Remo, which was a 4 kilobyte cache instead of the 16 kilobyte cache from the same design of Rice Creek. It became Remo because we are doing it at 180 nanometer. The other previous one was a 22 nanometer. This was a 180 nanometer design, but that's what's available at HCL. And that came out again in the year 2018. And that was also a first time success. So an young team, a fresh team, starting from scratch, first tape out, unknown technologies, unknown set of era. We boldly went and 2 successful tape outs within 6 months of the funding, November 2017 to July, August, within 7 to 8 months of the funding, 2 successful tape outs, and that gave us a lot more confidence. And the sincerity of the team, blessing of the God, these are some parts, and technically the help came much from BlueSpec. I owe that success to BlueSpec because it gave us a language in which we can define and confidently progress with the design with very less errors. And the productivity also, very small team, very stringent deadlines, and we have made it. And so at that point of time, Berkeley had Rocket, MIT had Risky, IIT had Shakti, right? So we had this. So essentially, we were able to compete and say, yes, we do exist. Don't erase us from the annals of computer architecture history. And that was very touching and very important moment for me. Now, in the year 2020, now, that is where this is a commercial grade chip of the E class, which is the IoT class that we had made. That's the 3rd tape out, and that also was booted successfully. And what I will do is that I will play a small 6-minute video before I go to the next. So Gopu, how much time I have? I'm 450. I thought I can go to 515.
Yeah, we have time. You can go on.
So I'm on time. So I'll go up to 5:15 and then we can take up queries. So I'll just play one short video of around 6 minutes. But this is the tape out. This is the chip that you see made in Chandigarh. There are 3 phases in the design. The design was done in IIT Madras. Then the mask was made in IIT Madras, sent to Chandigarh. Chandigarh, they did the fabrication, they packaged it, they sent back. The motherboard was done in Bangalore. The design of the motherboard was done in IIT Madras, done in Bangalore. Then some passives were imported. That's the only import in the board, and the chip was, and it was all assembled at in Chennai, and then booted in Chennai. So this is the ecosystem that we have built here. So from scratch, from design to actually post-silicon validation to have a board, and that board today is Arduino compatible. Arduino compatible in the sense that I could make all the Arduino type of compatible boards that were there. It could be fitted onto this motherboard. And this is what we achieved. And this is the sort of and we have touched the maximum. We expected 75 to 100 megahertz, and it did its 100 megahertz dot full maximum, and that is something which is very, very interesting. So I will just play a very short video for the benefit of all of you. Are you able to listen to the sound?
Yes, it's coming through. Yes.
Namaste. I am pleased to welcome you to witness the booting of Maushik, the youngest member of the Shakti family of indigenous RISC-V microprocessors, conceptualized, designed, and developed by the Pratap Subramanian Center for Digital Intelligence and Secure Hardware Architecture, PSC Disha, Vice Group, Department of Computer Science and Engineering, IIT Madras. This is the third chip that is designed and manufactured from the center. All the three are first-time silicon success. Maushik is a processor cum system on chip that would cater to the rapidly growing Internet of Things IoT devices that are integral part of smart cities of our digital India. Three steps are involved in the making of a microprocessor chip: the design, the fabrication, and the post-silicon boot-up. All these steps were done in India, demonstrating the existence of an Atmanirbhar ecosystem in digital design productization. The design was done in IIT Madras, the fabrication at the Semiconductor Laboratory Chandigarh. The motherboard, printed circuit board design was done again at IIT Madras. Manufacturing of this motherboard at Bangalore. Assembly and post-silicon boot-up at IIT Madras that you are going to witness. The Maushik silicon is manufactured using 180 nanometer technology with a die size of 5.315 into 5.155 square mm. It has 103 functional IOs. It is a CQFP package of 256 pins. The core voltage is 1.8 volt, while the IO voltage is 3.3 volt. The total gate count of the SoC is 647,000. The entire chip has been EFT tested, and it also houses the JTAG functionality. The Maushik SoC houses the Shakti E-class core along with a list of peripherals and peripheral interfaces. They include the PWMs, the SPI, GPIO, UART, the QuadSPI, I2C, and an SDRAM controller. The chip can run at a frequency between 75 to 100 megahertz and also has the PIN-MUX functionality at the I/O, enabling interfacing of multiple peripherals with the SoC. What you see here is the indigenously developed motherboard named Adronix version 1.0. The heart of the Adronix motherboard is the Shakti Maushik SoC. In addition, the motherboard has support for SDRAM. It has support for multiple peripherals like I2C, QuadSPI, SPI, ADC, etc. Importantly, the motherboard has Arduino compatible headers, which enables interfacing of various Arduino daughter cards available in the market with the motherboard. In addition, the motherboard also has switcher ICs, which enables power conversion across a large variety of voltages, thus enabling
a variety of peripherals to be interfaceable with the motherboard. The PCB is a 4-layer motherboard with an input power of 12 volt at 2 amperes.
Yes. Thanks to all the students and project staffs, the members of the Semiconductor Laboratory Chandigarh team, and the IIT Madras management for their support and great work done in spite of the COVID pandemic. Profound gratitude to the Ministry of Electronics and Information Technology, Government of India, for their generous funding under the Swadeshi Microprocessor development. Jai Hind.
So that was the Maushik boot up video, and which we were very happy and.
Okay, hello Tigers, and welcome to the Certified Solutions Architect Associate course. It's taught by me. My name is Ryan Cronenberg. I'm one of the co-founders of A-Cloud.
You have to stop your video.
Yeah, this was YouTube playing other things. Okay, now I just go into the next aspect of my talk, which I spent very important things on the Shakti vision, the Shakti sponsors, collaborators, and enables, and what is Shakti today, and the team Shakti, and the strategic needs from a national security perspective. Why Shakti actually became very important here. So Shakti today, if you look at, we have open source baseline course. We have interconnects and fabrics that will join these cores, join the different components within the chips. We have multiple peripheral device IPs, and now a lot more IPs from India. They are ready to be part of the Shakti ecosystem, and they are offering that they can make it available to the Shakti tapeouts. We have a complete design to layout flow, the entire flow, the ecosystem. We have good grip on taking this to the FPGA, the SDK, the software development kits, and the integrated development environments. And then this basically leads to domain-specific architecture. So I want to spend a little moment on what we mean by a domain-specific core. So if you take a strategic agency, like say a nuclear reactor, you try to make a hardware and a software, the entire system, there's something called a security certification. And they really do it because, if we are closest to a nuclear reactor here, a certification of a system actually takes, a complete certification takes at least 5 to 7 years. And then they expect that the system is in existence for next 15 years at least. So they are looking at a 20-year window for this. And by that 20 years, so you make a decision on your processor, you put it, next 20 years, you need a support, you need a supply of these processors. So what happens is, let us say even we have 20 years support, they take that much stock and keep it. But at the end of 20 years, suppose these processors are not available, there's the end of life. The new processor they bring in need to have the same set of interfaces that the old processor has. If the new processor they brought in doesn't have those interfaces, they have to change the entire board, essentially means the entire system. Then they have to go in for the same 5-year, certification process, detailed certification process, right? So there is a need for any type of strategic activity that they need to make processors that are state of art, at the same time adhere to some certain legacy execution or execution environments in which they are supposed to work. For example, they don't want to change the software. They'll just change the hardware, but the software remains untouched. That's also correct, because that will save half of the time. And for the software to execute, the same set of peripherals should exist. And that for me to put those set of peripherals, the peripheral interfaces should exist. And that is where this domain-specific course come into place, where it is going to be a major turn in the era of strategic computing. And we certainly envisage, and we are very confident that Shakti will play a very crucial role in all India's strategic programs like space, nuclear, and defense. And what we did to this MeitY, the funding agency for us, has today announced the Swadeshi Microprocessor Challenge, in which 2 microprocessors that are done in India, 2 series of microprocessors done in India, one by us, another by CDAC, both are RISC-V based. The Swadeshi Challenge has opened. We have around 6,000 participants, 6,000 teams who have come forward to participate in the Swadeshi Microprocessor Challenge. And there is around 4.5 crores is the outlay of this program, and they will be funded for taking their designs on winning to market. Right? And this is the next step that we have taken. And so we are here today. We are a small team, committed and dedicated team, and that has made this possible. And this is another opportunity another way by which we promote the use of this microprocessor across the country. And then we had all these people who had been with us, the ISRO, the Atomic Energy, the IGCAR, the BARC, HCL, Thales, and Western Digital, Intel, of course, on the industry collaborators who are working very closely with us today. On the other hand, from the tool sponsors, we have BlueSpec, Mentor Graphics, Synopsys, Cadence, and Xilinx who are working with us. And then there's a Semiconductor Laboratory, Department of Space, the Ministry of Electronics and Information Technology who are funding us, and RISC-V, and of course our alumnus, Mr. Pratap Subramaniam, have been funding this activity in a very big way. So the whole vision would be, now we are going to democratize and promote India-specific SoC design towards self-sustained digital technologies. And this is the cycle that we are breaking. There is a money, there is a knowledge, and then there is a fabrication that leads to money. This vicious circle was there. So we had the knowledge, and now there was somebody to fabricate. Now we are in this third leg of how to commercialize this and take it forward. And what we have here, we basically have the expertise in terms of building up the accelerators, the peripheral IPs, the fabrics, and the network on chips, etc. We are very thorough with the FPGA and ASIC flows. We have the operating system, the software components, IDs available. We have the complete verification, validation, prototyping, and compliance checking are also in place. This is the ecosystem that we have built. In addition, there is a startup that has, my students have taken it up under the guidance of Madhu, which is called InCore Semiconductors, which is now will be the first startup to take Shakti to a commercialized environment. And we expect many more people to start using Shakti in the near future. Now, the last, I'll just take another 7 minutes more. The last thing is the importance of Shakti, specifically from a say national security perspective, and that is where this is becoming extremely important and it has come out at a very nice juncture where we are seeing Gulwan, we are seeing our neighbor treating us, and this is really the time where we are trying to hit this hard. Now, if you look at, there is any system that is built, there is a human-machine interface, then there are certain computer algorithms, there is software architecture, and then there is the hardware. The hardware is where all your secret keys are stored, your first boot happens there. So the hardware is called the root of trust. It is the first thing that comes up alive. And if the hardware is weak, however good your HMI is, your computer algorithms or your software architecture, everything is, however good they are, however secure they are, if your hardware is weak, everything is gone. So hardware is the root of trust, and the security actually begins by building such type of trustworthy hardware. Now, the main issue now comes is security versus trust in electronics product domain. So the point is that if I buy a billion transistor, I don't know how to ensure security. So the security is basically somewhere implied by trust. Okay, he's a good fellow, he will not go and cheat me, right? So suppose I want to trust a hardware because it's coming as a black box today. Until we make our fabrication facilities available, it has to come as a black box. When it comes as a black box, what are all the issues that are coming? First thing is it is getting manufactured somewhere. Then there is a supply chain, right? And so after the manufacturing, there's a supply chain which brings it to the country. And before that, there is a design life cycle also that is available there. So when we look at supply chain, there are different ways, like you have the government off the shelf and commercially off the shelf type of things. And there is an end of life for that. There could be counterfeit, there could be dumping of it. So there is a design life cycle, there is a manufacturing cycle, and then there is a supply chain. And all this has to be trusted. Then only I can say, oh, this fellow would have not done anything wrong. Now, when we look at typical supply chain of any product, so this is what happened, say, I don't know, now with some global tensions, this might have slightly become different. But certainly, a US marketed product will actually start from Japan, go to USA in the terms of wafers, then it get bare wafer into fab wafer into it's manufactured, get into die, it is sent all the way to Malaysia, and from Malaysia it gets packaged, then it goes to Singapore, and from Singapore it goes to China. The chip is integrated into consumer goods, and then this again sent back to USA for selling. So this is what one supply chain, which is very cost-effective supply chain. Now, if I'm looking at a supply chain like this, and the chip goes all the way here and there, we don't know who adds what at what point of time, and what do we trust here. So the supply chain security is very, very important. And this is, so the between product design to packaging to components and systems and assembly, now you see at least 5 plus 5, 10, 11 countries involved in this entire thing. And that is going to become the ecosystem as a thing. And we need to start addressing trust and security from this supply chain perspective also. And then what could happen, see, suppose I know where it is manufactured, I know where it is packaged, but what could happen at a design level is that, at every stage of the design, you can basically keep, including some malice, right? So I can put untrusted hardware trojans. I can put some, a rogue employee can put a hardware trojan inside. There could be some unintentional vulnerabilities. At the foundry, there could be, you can, as an end user, I can put something, I can put a micro probing and get some data. So the hardware vulnerability can be introduced when you are integrating your system on chip, or when you are actually at the design level, or when you are doing the backend or the physical layout, or when you are fabricating after the end product has come, and then when it is being deployed. So this is the whole threat at design and manufacturing. And unless I have some sort of a control or trust at each stage, I'm not be in a position to say, oh, this is a trustworthy hardware. And that's becoming very important because millions and billions of hardware is going to come in. And that is where, at least the design should be ours, and at least the end product should be ours. The entire design, proprietary fabrication will be, then we start reducing this risk here. Okay, so this is where, this real stuff has come up. And the last one is what I'm mentioning. This is the team that has been today with us in the Shakti thing. I have Professor Chester Rebedio and Professor Pratyush Kumar, who are the faculty, and then all these students here and the project staff here. Some of them have not given their photos. So, but so this is the entire team, and we had n number of interns who had come and gone, n number of students who had participated. But this is a current team that is working with us, and that's why I put this here. And many of them are my ex-students who have come back and with a huge cut in their salary, and young people who wanted to really come and do some impact for our country. And that makes me very happy and very satisfied that we as a country are indeed able to motivate youngsters to give up some amount of Lakshmi to come and do some Saraswati here and upgrade the knowledge and do something great for the country. And I salute that passion for this. Right? So I will just stop here because of lack of time. I could talk for several days on this, but anyway, I'll stop here and I'll open up to questions.
Professor Kamakoti, there are plenty of questions. I will let you answer them, and whenever you want to stop, you can stop. There are about 15-ish plus more questions coming in as of now.
Okay.
So I will go on a chronological order from the first question onwards.
Sure.
Some of which you might have answered, but nevertheless, I will anyway, ask the questions.
Okay.
So first is from Victor. What is an educational and professional path that one can take if he wants to start a business in the field of fab, packaging plus testing and manufacturing? Considering these processes cost so much, what is a practical approach for an entrepreneur?
Okay. See, today, yes, there is an initial cost that is involved, and there will be a huge cost. For example, between a fab and a packaging and testing is a little low-hanging fruit, in the sense that today, if you want a state-of-the-art packaging and testing facility to set up in India, we need 1/10 of the cost of 1/100th of the cost of what we do as a fab. For example, state-of-the-art fab. Like for example, with say something like $50 million, we can basically start a fab facility in India, a packaging and test facility. As an entrepreneur, as a single entrepreneur, going into this would be a very difficult thing. What is necessary today is to basically understand the game very clearly, go and work. First and foremost, be very thorough in your basics. And that is where there's a failure, right? So very thorough in the basic is do the designs, understand what it means by packaging. We'll just go at packaging, testing, and assembly. Do what is digital systems testing. How do you make testable designs? What are the different state of the art? Learn those concepts very clearly at the university level. Be very thorough of those concepts. And today, yes, there are lack of good teachers. That's a whole bunch of educational problems, but that cannot be brought in because today we have enough amount of materials available on the on many platforms, including our National Program for Technology Enhanced Learning, which actually talks about many of these ventures. Once you have this very clear-cut basic foundation knowledge, then it is better for anyone, if you want to be in a fab or if you want to be in a packaging testing industry, to look for a job there and go and work in that industry for say 2-3 years or 4 years, get complete knowledge, and then come out, and then we can say that that particular experience, for example, especially in silicon and packaging, if you have the experience of say some 50 or 100 different products that you have done over a period of say 2-3 years, so it's possible 2 products per month, right? If you have done that, then the experience that counts will attract many investors to come to you and basically invest in your company. And unless that particular part is achieved, specifically in these two, the real competence of trying to go and make the hardware that will work, make a packaging that will be correct. If that is not that type of a competence you have, certainly the investors will come to you and they will give you money. Well, that has to be established, and once that is established from the government side, today there are a lot of PLIs. If you do a production in India, there are a lot of incentives that are coming for setting up this. There are multiple incentives. You can go to the there are even gazettes that have got approval of the government at the highest level for these incentives, and those incentives will certainly help you in the setting up process. So this is a sort of a broad answer. So it is always Saraswati first. Get to understand the game very nicely. Go to the company, work for 2-3 years without shifting. Completely understand everything. When I was joining IIT, I went to Jayendra Saraswati Swamigal, and I said I'm joining IIT. I gave the appointment order. He put kumkumam and gave me. Before he gave me, he just pulled it back and he said, "Day." He said, "See, I am in the smut. I get up at 4 p.m. in the morning and work till 11 in the night because this mud is feeding me. So there'll be a lot of things unattended. We have to just take something and for yourself, and people may appreciate it or not appreciate it. But at least when you look at back, you have the satisfaction of doing something, and that's how mud works. There are so many unattended things, and somebody will take it and attend to it and make it big. Similarly, IIT is also like that. There will be a lot of things that is spread. You have to take interest and start building things there. Then only at the day of retirement, you will happily retire. I can't say they will give you some award or anything, but certainly you will retire as a happy man. That's the advice he gave. Similarly, if you go to this industry, they will tell you do only this packaging of QFN. You go poke your nose, find out what is BGA. You go poke your nose and slowly make friends, understand the trick of the trade, and that is very, very important. So that inquisitiveness to learn is the first step. So this is Saraswati first, and Lakshmi will automatically follow. Like when you are going towards the sun, how the shadow follows you. When you are going towards Saraswati, Lakshmi will follow. Okay.
Next, a question from Pulkit Jain. Hi, I run a startup developing electronics hardware product. I am looking to use Shakthi Processor in my design. How can I set timelines for something like this?
Right, exactly. Good question. First and foremost, we would like to understand what is the product that you are doing. First and foremost, we could have actually be a part of the Swadeshi Microprocessor Challenge. It is late now, it is closed. Probably this talk should have been a little earlier. Then I could have asked you to come to this. So you please contact me at kama@csc.iitm. Just put Kamakoti IIT Madras. I'm the only guy there, so you'll get the first hit in Google. So you just send me a mail and we will guide it through. And setting up the timelines, this is the way, right? So this is a cycle in which everybody is. The cycle here is that we are trying to make the commercial level Shakti processor available at the shortest. Of course, we are facing fund crunch, but we will certainly get through that, and we will make a couple of processors available on a commercial basis. But then the volumes have to come. Only when the volumes come, the cost of these processors go down. And so now what we are trying to tell the government is at least now make the chip available, and then let us see how the volumes come up, right? So that is the stuff. So we are trying to bake the chicken and egg by just getting the processor up. So we are looking at least 6 to 7 months by which we could get at least the C-class processor out. But anyway, you can come and discuss with us on the progress, and then we can take it forward. You can just send me an email and I will respond to you specifically because we need to understand more about your product.
There's a question from Akshay Veeraraghavan. Says, are there any tutorials online to learn RISC-V?
Of course, there are. Just put RISC-V. I'll even demo you. If you can just go type RISC-V, you get half of the 5,000 links.
Okay.
And we also have a RISC-V training as a part of our shakti.org.in.
Yeah, there was also a response, I think, from Kunal that a workshop is about to be organized soon on RISC-V.
Yeah.
Okay. So a question from Srinivasan Narayan. Some months back, Zoho informed that they would start a fab industry. Any idea about the progress? Is there any conversation from Zoho and you on anything related to this by any chance?
at this point we don't have, but but certainly if Zoho would want it, they will surely set up. We salute Zoho for many of the initiatives they have taken. Specifically, one thing as an academician, but I also run a rural school. I always feel bad that our rural intelligence is not basically tapped. We have so much of rural intelligence, and that we are not tapping. I think Sridhar Vembu sort of is the real promoter thing, has taken this to a place like Tenkasi and is able to do a wonderful job there. Salute Zoho. And if we are not in touch with them regarding a fab, but if they really want, I think surely he will achieve. We wish him all the best and all the support.
Okay. Raman Ramanujan asks, can anyone have a startup based on this chip, I guess? How will he get assistance? So that's
okay. So this is the thing. So on the startup front, so two things. One thing is IIT currently is supporting this. Shakti.org.in has a complete thing. It has a blog and it completely supports on your stuff. And if you really want to take it to FPGAs today for prototyping, all those tools are all available. And there is a startup company, Incore Semiconductor. I just the slide I will put. Yeah, there is an Incore Semiconductor, which is it's a commercial, it's a startup company, and that will be giving a long range support to this. They will be supporting it beyond IIT. IIT will do this for some time, and then we are going to make it. We are already open source. At some point of time, it is for the industry to take it up. And which industry today, Incore Semiconductor is there, it can give you a long-term support for this activity.
Krupa Samudran has asked quite a few questions. I will organize them properly and I will give a couple of them at a time. How does Shakti family of processors handle the vulnerabilities of SoC design? Controllers for memory peripherals like LPDDR3 and DDR4 memory chips, PCI Express, etc. Also, what is the status of fab in India? Is 180 nanometer enough? Does the fab have rich library to support various IPs?
The first question, Badri, there was a small disturbance. What was the first question?
Yeah. How does Shakti family of processors handle the vulnerabilities of SoC design?
Okay, right. So, so this is a very interesting question, and Kripa Samudran actually is the Venkat that I showed earlier, right? So he's part of my team. I have been questioning him in the morning, so he's taking revenge on me. Okay, so the very important question. I think he's asking this question to provoke this answer. So see, BlueSpec as a language, right? As a language is a rule-based language. So it supports something called it supports formal verification. Though now it is almost a sort of in a beginning stage, but over a stage we are very confident that we can build formal tools which can do a formal verification of the design. What do you mean by formal verification? Today, when I buy a processor, I'm sure I can find out very quickly by giving inputs whether the processor does what I want it to do. But what is more interesting from the security point of view is whether the processor will not do what you don't want it to do. And what I don't want the processor to do is all the way from I don't want it to cook to anything, right? So that's a huge thing. So that's an unbounded, uncountably infinite set. Okay, so I can't do anything of that. So formal verification gives answers for both. It says that okay, it does what you want to do, and it does not do what you don't want to do. So that is one very interesting thing, and that comes because we are using BlueSpec, which is a highly rule-based language. The next thing is that we are making the secure hardware today. We are looking at microarchitecture level security. So that's one thing I told you, that security in the slide, right? So see, security is like a habit, right? And the habit in the Tamil. So I don't know if many of you are Tamil. Anjila valayada, ambadula valayada, right? What the habit you didn't inculcate at the age of 5, you can never inculcate at the age of 50. Say till 49 years, 364 days, you are getting up at 10 o'clock in the morning. 50th birthday, asked you to get up at 5 o'clock, will kick you, right? So this is how. Similarly, security is also like that. You have to build, the processor has to grow with security. Now, many of the legacy processors have forgotten security, and now they are trying to retrofit security after its 4 or 5 decades of existence, right, on the legacy architecture. And that's why we see a lot of this Spectre, Meltdown, so many things that have come up. Now, what we are doing, this by being a young baby, not even 5 years old, we are now teaching it at a fine-grained level. We are trying to put security. If you have carefully looked at my slide, I said fine-grained security at microarchitecture level. So we are getting something like secure boot, compartmentalization, and at physical memory protection. So many things together will make it a very secure architecture. In addition to that, there is something like, you have a chip. From remotely, I'm just measuring the power it is consuming. And I know that if it is processing a 0, it is consuming less power. If it is processing 1, it is consuming more power. Just by looking at the power consumption pattern, I can reconstruct what is the key that you are processing. And this is called side channel attack. One of experts, Professor Chester Ribeiro, who is in my team, is an expert in that. And we are trying to make designs that are side channel resistant. So by just measuring this power, people cannot find out whether I'm processing a processor, the microarchitecture is processing a 1 or 0. So these are some of the very interesting things that we are looking at from the security point of view. The second question, Badri, I just...
it is, what is the status of fab in India? Is 180 nanometer enough? Does the fab have rich library to support various IPs?
Yes. See, one of the wrong things that had been happening in the past is that people said, "Oh, 180 nanometers, 20-year-old technology," and they have been, making such type of irresponsible statements. 180 nanometer is today relevant. India needs around 1 million wafers a year to satisfy even her own needs, right? 180 nanometer is a place where we do all the voltage level chips, right? We have so much of solar, we have so much of EV, even in the mobile phone, we have so much voltage chips, right? So 180 nanometer is a very, very relevant fact even today. And the thing is that is why, HCL can be easily upgraded and we will satisfy our own needs initially. But then there are certain designs based on basically performance and power, like the processors, advanced processors, that may need, it's 28 nanometer or a 40 nanometer. And that fab has to be set up. So we do have an infrastructure today which needs to be quickly leveraged, and we make a bigger fab today, which can quickly start making a manufacturing ecosystem in the country, like make the chip, package it, and so many things, so that we are comfortable in producing chips from the country, whichever nanometer it is, but it's relevant, and we consume it within our country. I think that is a good Atmanirbharta that we can achieve closely. And then we look at the 28 nanometer in the short period. Anyway, within the next 3-4 years, if we don't get a 28 nanometer and also enhance the 180 nanometer, we are losing the game. And I think the government is certainly aware of this particular fact and will be taking up many steps in that direction.
There's a question from Balaji Rajan. Is there some data on commercial comparison between this and what is available and imported in India?
Yes. Processor? Yeah. I assume that he is talking about the processor.
Yes.
So as I had mentioned very clearly in one of the slides, you can just visit, we are actually, each of the processor that we have designed now so far is actually trying to meet the performance of one of the contemporary processor in that area. So that is, we have kept that in mind. So as I initially also told, that we don't want to sell it because just we made it in India, because it is a world-class product. So just because it is made in India, but it is also a world-class product. So we have always been very careful in designing this processor and orienting this processor towards meeting some performance of a contemporary processor, and we have that in mind, and we are doing it. And the leapfrog will come. Probably a catapult will also come, that we'd like to do much more. A pole vault will come when we try to bring in the security and edge intelligence. And that's what we are envisaging in the next 2 years.
There are a few more technical questions which I'll skip, and I'll jump to a couple of other general questions so everybody can understand. So Srinivasan wants to know, how about the OS for different application domains? Only Linux, or would there be other OS?
Very nice. So very interesting question. So it's not only Linux. We have a complete set of multiple operating systems like FreeRTOS and other many OS that are already booted on this. We are also trying to boot the microkernel on top of it. A microkernel is one which can be formally verified and which boots up first, and we can certify that it is working correctly. And it, on top of it, you can para-virtualize or full virtualize an operating system. So this becomes an extreme level of security that you can build in this. And we are also trying to boot many of this. So it is not just one OS. There are many OS that we have already ported, and many of them are RTOS, including Linux. We have a Linux port also. Thank you. Except for Microsoft Windows, we have all other ports as of now.
There's a question from Ramaswamy. Is it comparable to a typical Arduino, say 400 milliwatts? I think it's milliwatts. What would be rated chip temperature in terms of ambience and internal heat generation, and say the junction temperatures?
Okay, so this is a very technical question. I'll certainly see. Please send me an email. I don't have immediately that answer, so I can basically send you this answer.
Okay. So again, one more question from Srinivasan. Every conceivable product design has a short-range wireless connectivity, Wi-Fi, Bluetooth, etc. support. Any plans to support any wireless technology as part of the SoC ecosystem?
Yes. So very good question. So at this point of time, what we have shown is that we have this MSP232 or one of those chips that we have already shown that we have connected it to the SPI, and we have already shown a wireless connectivity outside. The processor can communicate outside. And the only thing is that we need the IPs of this. If I want to put it inside the chip, we need the IP. And of course, we have the complete wherewithal to do a mixed signal design. That will not be a bigger issue. But the only point now would be the IPs. And once IPs are available, we'll certainly take up. We are also working with some startups in India who can have these IPs and who can put it inside as a part of the
Anupam Bakshi asks, what do you need Indian semi-EDA industry to do to help? I guess he's probably from the industry, but he wants to know what kind of help do you need from the Indian semiconductor EDA industry?
From the EDA, see, for example, the electronic design automation tools. If he's talking about the tools are foundry specific, and there are these tools. The Ministry of Electronics and Information Technology has this SMDP, Special Manpower Development Program, which is as old as my career, like 20 years it has been there. So the tools are made available. And other than this electronic tools wise, we also have this what you call as the PCB tools, and also those infrastructures are available. As such, the point is the way industry can help is to use Shakti. They need to come forward with use cases for Shakti and with an open mind start using it. And of course, if you look at a commercial processor, there could be a little more support than this, but the support will actually come up as and when we start using it. So the use cases will bring up some of the gaps, and we will fill up that gap. But what we can assure from IIT Madras and also from INCOR Semiconductors is that these gaps will be filled very quickly, so that we can take it.
There have been plenty of questions, quite a few questions on the commercialization, go-to-market strategy. Some of which you answered. There is a startup, etc. But do you want to highlight a little bit in terms of go-to-market strategies?
Thank you, Badri. I think this is a very interesting question. So there has been this question of what will we commercialize? So should it be closed to core or an open core? So the first test I did, I want people to look at datalibre.org.in. So IIT Madras went ahead. So I was in the board of a bank, City Union Bank, and myself, my cousin who's the MD, we have sat through at least some 4 to 5 dozens of presentation on this data analytics. And then finally somebody will come, they'll wear all coat suit, everything, and finally say, oh, this thing is rising, this is stop. That doesn't need a data analytics. So we got fed up, and then they say crores of rupees for these products. So we decided, okay, let us try and do something which would be an open source one. Because this data analytics will keep killing you. We need data for business, and they keep scaring you, right? So we started this datalibre.org.in under some funding from City Union Bank to IIT Madras. it's an open source thing. And then there was, so today there are a couple of startups. One is Resilio Labs, which are actually using this. They participated very much. So we today also have a performance monitoring tool. You won't believe today the entire Arogya Setu, the performance testing of Arogya Setu. So when PM announced this Arogya Setu, there were 25,000 hits per second. Okay, and we really wanted to find out whether the server will take. So we wanted to have concurrent user test that we want to do preliminary performance testing, and then security testing, and then the backend. All these are done on top of this open source platform, completely done. And this would have saved at least millions of dollars for us, because we want an equivalent commercial license for doing this type of performance tool. It would have created. Now, that particular open source tool, there are many people who are using it for training and also commercial, this thing. We have given it free. So they do it, and they actually customize these environments for the people and make money with them. So the customization is the business. The model of this commercialization is the customization. So what we also believe is that we want to find there is a $1 billion market for processors, $1 billion companies there, and we now go with this Shakthi processor. The way we want to look at this is very straightforward. We now say that this is free. This under BST license. You take it, you do whatever, you need not even acknowledge. Take it free. Right? Now, there can be startups who can take this up. They will go customize it for the customer's need, and the customization will fetch them money. And I believe that will fetch more money than actually holding the full IP. This is the democratization that we are doing.
Brilliant idea. There is a question from Chandramouli Parasuraman. Are there initiatives either by Government of India or others to bring out devices similar to Raspberry Pi, Arduino that can use Shakti?
I don't immediately. I can't say whether it is from government. Why government? So, but there are a lot of interest generated by local industry and enthusiastic people who want to do an Indian Raspberry Pi using Shakti, and we are basically in that process. If Mr. Chandramouli is interested, he can also join the bandwagon. So anybody here can come and join us. Okay, price is always open.
Okay, I think we have had quite a few questions, and there were also a little more technical questions which I've sort of skipped and let them directly mail you and get the details, because many of those even the abbreviations will not be understandable to people who are not familiar with the area. But it was your lecture was very easy to follow, get a overview for even somebody who does not understand the nitty-gritties of chip design, where we can really understand the importance of something like this, how the history of how it has come about. So that was quite fantastic. In fact, there are questions now coming up on how to join the group, and there are lots of congratulatory messages, thank you, etc. I will let them all email you, and perhaps you can have one of your assistants take up all those questions and figure out the response. But it's really created a lot of enthusiasm. I can see that there are quite a few students, people from the industry, people who are quite knowledgeable about the field, who are following the talk right through. Thank you. This is a fairly unique talk for us. I mean, basically, we have had a lot of science talks explaining things that have been there for centuries, or new invention of something that was fairly there for a long time, and when we are trying to figure out, it's one of the first instances where we have heard a lecture on a technology that is emerging, and a competitive one at that, compared to what is happening around the world. Many people have asked for your email address. I will. Is it okay if I share on YouTube? Okay, I will do that. I will provide his email address. So thank you very much, and this is a very very entertaining and very informative, and we really wish that more great things come out of this this project as a continuation of this project. Gopu, do you want to add anything?
I want to ask one small question. It's kind of a very generic question, if I may ask. There is talk that, so one actually one comment I will say that adding on to Badri's, this lecture made me aware of what an entire environment there is for the semiconductor industry, the computer industry architecture that most of us are generally not aware of. We think of computer chips as something to do with it's all US and Korea and maybe some fabrication plants in China, and that's all it is. So next to nothing about this. We don't get to. So that was, in that way, it was more very revelatory. So that was very interesting. There are people have been espousing that or predicting the death of Moore's law forever. They've been predicting the death of Moore's law pretty much 5 years after Moore came up with this law. But they are saying that we are actually going to Intel and others may actually hit that limit anytime in the near future. If that really happens, is India in a position to kind of catch up, because they can't progress any faster, and then we'll catch up, just by following and following the red lights and come at the same stop? Are we in a position to do that?
Right. So it's a very, very important question, and I'll give you a Lakshmi answer for it rather than a Saraswati answer. Okay, right? So because that is becoming more important today. So 180 nanometer. So this is all about nanometers, right? Moore's law is always about nanometers. And 180 nanometer is the 1998 technology, right? That's the year my daughter was born, so I relate it to my daughter's birthday. Okay, so now it is 20 years now, 22 years now. Now, but it is relevant in sense it has another 10 years of lifetime at least. My opinion is that 40 nanometer will have at least 25 more years of relevance. Because there are certain things that you need to do on a daily basis, for which I don't need this 5 nanometers, 7 nanometers. So today, 5 nanometer protection will come within another 3-4 years, and that is still Moore's law. 7 nanometers already in production, and that is still Moore's law. So people say that we can go up to 3, but then it will stop. Commercially, these technologies that came out of Moore's law will exist for at least another 40 years. There's no doubt about it. There will be relevant chips that are going to come out of it. As you are seeing, relevant voltage domain chips still at 180 nanometer coming even into your mobile phone. You will see that type of chips coming up. So there is no doubt. But then the next part is very important, that we see that the post-CMOS devices and so there has been a lot of work that is happening across the IITs, IISc, and many of the leading educational institutions at this point of time on the the alternatives to silicon. That's the post-CMOS devices, including carbon nanotubes, etc. Silicon photonics is also coming up in a big way from an interconnect point of view. It could give us a better speed and better reliability also. So these things. The main issue is that the amount of funding that will be needed to actually practically realize this will be the turning factor. We will have very good ideas, even about quantum. There are startup companies in quantum key distribution, right? And even we have one from IIT Madras. So the point is this: this as a technique, if it wants to become sort of prominent, and India has to take a leapfrog on it, will demand a set of a set of funding, which is a risky funding, because it may work, it may not work. And it's all up to whether the government will be funding it to take this risk, and will there be somebody who is going to accept that funding and willing to take it. So that's the biggest problem here. And so the whole thing would be not the physics part, because a lot of physics, not the electronics part, and beyond this physics and nano electronics and the mathematics. It is going to be the fabrication part, and whether such type of fabrication, facility, setting up, how to conceive these devices. My opinion, it may not be a single country affair. Maybe US can do, but it may be a multiple international consortium that will come out with this, and then whoever is part of the international consortium will have the first access to it. So this is my overall judgment.
Wonderful. Thank you very much for your patient answering of all the questions, and very informative talk. Thank you from Varamigra Science Forum, and we're really happy that we could organize this talk. Thank you.
Thank you very much.
Thank you. Bye bye.
Thank you, Professor.
Thank you.
Thank you.
Thank you. Thank you, Goku. Thank you, SL. Thank you. Thank you.
Thank you. One of the most well-received, well-attended, and one of the most engaging sessions we have had. So many comments, and Badri is struggling to collect them all. I think that shows the quality of session today. Thank you, Professor.
Thank you.
We'll announce next month's program on our forum, Facebook page, WhatsApp, and so on. So thank you all for attending this lecture.